Hear and see me properly? Just confirm that quickly in the chat. Am I audible and visible now? Am I audible and visible? Okay, fine. Okay, I hope I'm audible and visible now. Hello, Maflook. Hi, Joins Gaming. Okay, yeah, there was some technical issue due to which I was not audible to you. So we are over here with factorization of polynomials on the Infinity Learn class 9 and 10 YouTube channel. In the previous session, we did the remainder and factor theorem in the Pratham series on this channel. In this session, we are going to do factorization. So are you guys ready? Hello, Sayyid Qazim. Welcome to this session. Okay, so let's start with it, guys. Only 2-3 things we are going to do, but they are very important. The factorization of a quadratic polynomial using splitting the middle term and the factor theorem, and then factorization of cubic polynomials as well using the factor theorem. It is very important actually. Hello Lokesh, welcome to this session. So let's start with it. So before actually starting with factorization of polynomials, let's do a simple question on the basis of factor theorem. Can you try doing this? You have to find the value of k if x minus 1 is a factor of the given polynomial over here. Lokesh, पहले ये कर लेते हैं. I hope that is better. Download lectures मिले. Downloaded lectures you can download. It's obviously on the website on the Infinity Learn class 9 and 10 YouTube channel only. Qazim, I hope you understand. Jonas Gaming, welcome to this session. Downloaded lectures नहीं मिलेंगे, लेकिन जो भी lectures हम कर रहे हैं वो सारी चीजें already recorded रहती हैं. यश, लेकिन but it is not visible to me as यश. चलो, so try doing this question. Let me know the answer, guys. It's on the basis of the factor theorem only. मैंने तुम्हें hint भी दे दिया है. जल्दी से बताओ मुझे इसका आंसर क्या होगा. Just confirm that quickly, guys. So over here, just suppose कि name of this polynomial is p of x. For a while, you can obviously assume that now it is given in the question that x minus 1 is a factor of this polynomial. So using the factor theorem, what can I say, guys? I can say that p of 1 is equal to 0 because x minus 1 is a factor of this polynomial. It means in place of x in this polynomial, I can put 1, right? In place of x, you can put 1 in this polynomial. Plus k, that is equal to 0. So just solve this equation and you'll get the value of k over here. So you see this is 4 plus 3 minus 4 plus k, that is equal to 0. So you can cancel out 4 over here. So the value of k is coming out to be minus 3. So the value of k is minus 3. Any doubt in this thing? Get this lecture on YouTube. Obviously, Qazim, just check out the playlist named as Pratham for grade 9 students on the Infinity Learn class 9 and 10 YouTube channel and Pioneer for grade 10 students on this same channel. So over here you've got everything. सारी recordings तुम्हें मिलेंगी. Last year के भी जो 10th के students थे उनके लिए हमने बोर्ड ब्रह्मास्त्र सीरीज किया था. उसमें सारी चीजें हमने for maths and science we did. So वो सारी चीजें तुम देख सकते हो. We did many short lectures as well and obviously we'll be doing that in the upcoming future as well. So ये सारी चीजें it's already there on the Infinity Learn class 9 and 10 YouTube channel, Qazim. So is the question clear to every student in this session? It's a very simple question on the basis of the factor theorem. Because x minus 1 is a factor of this polynomial, you can say that p of 1 is equal to 0. It means in place of the variable x, you can put 1 in this polynomial and the value will be getting to be equal to 0 only. Is it clear to every student in this session? पूछो यश, what is your doubt? सबको क्लियर है गाइस? जल्दी बताओ. Any doubt in this session? It's PM, Sayyid Qazim, Yash, Lokesh, Jonas Gaming. Is it clear to every student? Okay, Shanu. I hope it is clear सबको. Chalo. Now let's do factorization of polynomials, right? So you see you've got this question. We have to factorize this polynomial by splitting the middle term and by using the factor theorem as well. Hello Nawaj, I hope I'm pronouncing your name correctly. So you have to factorize this polynomial using splitting the middle term and also using the factor theorem. So try doing this and let me know the answer over here. First we can do it using the splitting the middle term, which you have been doing it since, I think since grade 7. Hello Nawaj. So over here we have to do it using splitting the middle term. So first method I'm explaining using the splitting the middle term to factorize this polynomial 6x square plus 17x plus 5. So what do you do in splitting the middle term, guys? In splitting the middle term, you have to see the first term and the last term, right? So you can do it in your mind as well. You don't need to write it, but I'm explaining, therefore I'm writing it. Hello, Amarnath, welcome to this session. Good afternoon. So what you do, you multiply the first and the last terms. You can do that in your mind, but I'm writing, therefore I'm explaining, therefore I'm writing. So this is 30x square, right? So you have to break the middle term. You have to split the middle term in such a manner that the product of those two terms is 30x square only. This has to be 30x square. So you see 17x, can I write it like this? 15x plus 2x. Why we are writing it like this? Because 15x into 2x will give you 30x square. Is it clear? Exactly. So in that manner we can do this splitting the middle term over here. So you see this is 6x square plus 15x plus 2x plus 5 over here. So you see this is the first term, this is the second term, second group over here. The first group, the second group. Out of the first group we can take 3x as common and you will be left with 2x plus 5 over here. Out of the second group I can take 1 as common, so I'll be left with 2x plus 5 over here. I hope that is clear up till here. So out of the whole expression, can I take 2x plus 5 as common, guys? I can take 2x plus 5 as common, so I'll be left with 3x plus 1. So you see this is the factorization of this polynomial using splitting the middle term. Is it clear to every student in this session? Kazim, Shanu, Yash, Nawaj, Amarnath, any doubt in this thing? Hello Ashik. Any doubt in this factorization of this polynomial using splitting the middle term? So we have got 2x plus 5 and 3x plus 1. That's how you factorize a quadratic polynomial using splitting the middle term. Now suppose I give a small question to you on the basis of this thing only. Can you factorize this polynomial, guys? Can you tell me what is this t square minus 5? After factorizing this polynomial, what will you get? Tantve, I hope it is clear. I hope I'm pronouncing your name correctly. I'm sorry if I'm not doing so. So what will you get after factorization of this polynomial? You see this is also a quadratic polynomial, right? T square minus 5 is also a polynomial of 2 degree, right? We already have done these concepts on the Infinity Learn class 9 and 10 YouTube channel in the Pratham series only, right? Exactly. No, it is there in grade 9 as well, Yash. After this, we will be doing using factor theorem as well. You see, Yash, this thing you can say this was there in grade 7 as well. Splitting the middle term was in 7 as well, was in 8 as well. Yes, you are right if you say. Hello Snell, welcome to this session. Yes or no? So you see we have to factorize this. So this type of polynomial you will not be able to factorize using the middle term because there is no middle term over there. So you have to use a different identity, right? So can I write it t square minus root 5 the whole square? Yes or no? So you see, isn't it of the form a square minus b square, and a square minus b square is nothing but a plus b, a minus b. So therefore t square minus root 5 the whole square, I can write it like this, t plus root 5 into t minus root 5. So that is the factorization of this quadratic polynomial. I hope it is clear, t plus root 5, t minus root 5, right? So it's, what is the meaning of that? That every time you will not be able to factorize a quadratic polynomial using splitting the middle term, right? So you have to use many a times algebraic identities as well. I hope this is clear to every student in this session. Now let's factorize this polynomial using factor theorem as well. It is very, very important to understand the factor theorem. The reason being, maybe you can factorize a quadratic polynomial using splitting the middle term, but if you get a cubic polynomial or a polynomial of higher degree, you will not be able to factorize it using splitting the middle term. You can do that, but it will make it very complex and it will waste your time. And that is the reason you have to learn properly how to factorize a polynomial using the factor theorem. It is the most important thing which we are going to do in this session. So try to see on the board properly and try to understand this thing over here. So factor theorem. So basically you've got this same question over here, right? So you see over here, when suppose a and b are the zeros of a polynomial, right? A and b are the zeros of a polynomial, suppose. Can I not write that polynomial like this, x minus a, x minus b? Can I write that polynomial like this, guys? Using the factor theorem, if a and b are the zeros of a polynomial, we can write that polynomial like this, x minus a, x minus b. Now the question is this the only polynomial whose zeros are a and b? The answer to it is no. Because if you multiply, suppose this polynomial by 5, still the zeros of this polynomial are a and b, right? If you multiply this polynomial by 8, still the zeros of this polynomial are a and b. If you multiply this polynomial by any non-zero real number, I am multiplying this time by root 2, still the zeros of this polynomial will be a and b. It means there are infinite such polynomials whose zeros are a and b. It's not just a unique polynomial, right? Hello thrower, welcome to this session. So infinite such polynomials are possible whose zeros are a and b. So what does it mean? That I can take a non-zero value k over here, right? Any non-zero real number k can be there. So k can vary, right? So infinite such polynomials are there whose zeros are a and b. So I have to split this, I have to factorize this by factor theorem. So basically I have to write this thing in the form of this or not. You understand it very properly, it's a very important thing. So can I take this polynomial and can I take 6 as common? So I'll be left with x square plus 17x plus 5 by 6 or not, sorry, x square plus 17 by 6x plus 5 by 6. Can I write it like this if I take 6 as common over there? I hope that is clear. Yogit, please watch the recording of the previous session. We already have done a session in detail and have practiced many questions over there. Please try to understand. If you want to obviously understand everything properly, you have to follow the whole series properly. I hope you understand because there is a time limit as well, right? I hope you understand that properly. So I can take 6 as common. Now see, the same polynomial can be written like this or not. I don't know anything. So can I not say that suppose a and b, they are the zeros. So can I not say it is something like this only? Yes or no? I can say it will be something like this only, na? If a and b are the zeros. So suppose if you multiply and open it up, what will you get? You will get x square minus a plus b into x, a plus b into x plus ab. You'll get something like this over here or not. You don't have to do these things in your answer sheet. I'm just explaining it. It is a very, very important thing. Please try to understand that. So if you compare this thing, with this thing, what does it mean? That AB is equal to 5 by 6 or not? Can you say over here that AB is equal to 5 by 6, guys? Yes or no? So basically A and B are numbers whose product is 5 by 6. So what does it mean? Can we not predict the zeros of this polynomial? So the zeros can be, what are the possible values of A and B? Tell me. A and B are the zeros of this polynomial, yes or no? So can I not say that the possible values of A and B can be plus minus 1 by 2, plus minus 1 by 3, something like this, they can be or not? Plus minus 5 by 3, something like this or not, it can happen? You got that logic or not? See, that is the reason I am saying, gamer, if the basic is not clear, you will not be able to understand that. We have already discussed everything in detail in the previous 2-3 sessions. Please follow the Infinity Learn Class 9 and 10 YouTube channel. See, there is a time limit to every session. So if I start from the very start in every session, will not be able to cover, will not be able to complete on any day. I hope you understand that. It is not possible to start from the very start in every session. That's what I was saying this to Yogit as well. So please follow the Infinity Learn Class 9 and 10 YouTube channel. I had explained in very detail, from the very basics, I had explained what are polynomials, what are zeros, what is the degree, everything I had discussed. So these are the possible zeros and so on or not, tell me. I mean, basically you want 5 by 6, two numbers whose product is 5 by 6. So A can be like this, A can be like this, A can be like this or not, tell me guys. So basically over here we have got minus 5 by 2 and minus 1 by 3. You see over here. So plus minus 5 by 2 can also work. You got it or not? Basically you want 5 by 6. So these are just the numbers which can be multiplied to make 5 by 6. You got that logic or not? You got that logic? Now by hit and trial you can find what are the zeros. Although we have done this question, so minus 5 by 2 and minus 1 by 3 will come. You see minus 5 by 2 and minus 1 by 3 will come because we have already factorized it using splitting the middle term. So what you can do in order to find these zeros, can I not put and check? So basically I will put in the polynomial 1 by 2. Suppose this polynomial is p of x. You can put over here. Suppose this is p of x. So if I find p of 1 by 2, you can keep on finding like this. If I find p of minus 1 by 2, if I find p of 1 by 3, all of these you have to put and check in the polynomial. You have to put and check in the polynomial, right? So that is use of factor theorem, right? So you will find that at these two values, because we have already done splitting the middle term, so you will find that p of minus 5 by 2 will come out to be equal to 0. And also p of minus 1 by 3 will come out to be equal to 0. Tell me, is the whole explanation of factor theorem is clear or not? That why do we actually do? This is very important and this is not advanced at all. It is the very basic concept. It is given in NCERT. Actually, this question is also from NCERT. I am telling that to you. So why you are actually doing this, I hope it is clear or not. So in many books you must have seen this is called rational root theorem or integral root theorem. So you might get scared that, oh my god, what is this name, rational root theorem and integral root theorem, so complex things. These are not complex things, very basic logic it is. From the very basic definition of polynomials, we are getting that the possible values of a and b can be these, right? More than this can also be there, but I am just giving an example over here. Is it clear? But already we know the answer. See, right now I'm doing a bit of cheating over here because I haven't put all the values, because I'm being honest, I don't have space. If I will put values over here, I'll not be able to solve for even 1. But if you will put minus 5 by 2, you'll get 0, and minus 1 by 3, you'll get 0. But obviously you will say now that from where to start. So you have to start from the very basic. Put 1 by 2, put minus 1 by 2, put 1 by 3, put minus 1 by 3, put 5 by 3, put minus 5 by 3, put 5 by 2, put minus 5 by 2. Automatically you will get those two values at which the value of the polynomial will be equal to 0. And that is the meaning of zeros. So if p of minus 5 by 2 is 0, what will you say? That minus 5 by 2 is the 0 of that polynomial. Is it clear to every student? Okay. Hello Deepika. Is this clear to every student? Yogit, Thrower, Mitansh, Gamer, is it clear? Snell, Deepika, Moanza, welcome to this session. Is it clear to everybody in this session? So that is the meaning of factor theorem. I mean factorizing a polynomial using factor theorem. It is as simple as that, right? Now suppose we'll do one more question. Can you factorize this polynomial using factor theorem? Splitting the middle term, I am assuming that you already know because you have studied that in grade 7 and 8. Answer is 0 means what? Hello Yash. Answer is 0 means what? Oh, are you talking about this p of minus 5 by 2 Yash? Yeah, that will be 0. See, p of minus 5 by 2 will for sure come 0 because minus 5 by 2 is a 0 of this polynomial. But you will see that p of half will not be 0. P of minus 1 by 2 will for sure not be 0. P of 1 by 2, P of minus 1 by 2, minus 1 by 3 will be 0. This will be 0. Except these things, at any value, the value of the polynomial will not be 0. Because only these are the zeros of the polynomial. That is the meaning of the factor theorem. I hope it is clear, right? And also we know that this answer is correct. The reason being, we have already factorized it using the splitting the middle term in the previous slide. So minus 5 by 2 and minus 1 by 3, therefore we are getting. So can you do this question using factor theorem? Try not factorizing it using the splitting the middle term. You already know that. Try using the factor theorem only. See, again I am saying why knowing the factor theorem is important. The reason being, quadratic polynomial you can factorize every time, but when you will get a cubic polynomial, you will not be able to easily factorize it, or maybe a biquadratic polynomial, you will not be able to easily factorize if you don't know the factor theorem. I hope you understand that. This one is a quadratic polynomial, this is very easy, we will do cubic polynomials as well, don't bother. So over here what is happening? See, this is a polynomial which can be written like this or not. Suppose its zeros are a and b. So this can be written like this or not. See, the leading coefficient is 1 only, na? So this will be 1 or not? Tell me. This is known as the leading coefficient, the coefficient of the highest exponent of the variable. So that is equal to 1 only. So basically, if you will compare, if you will multiply, although you don't need to multiply every time, but I'm explaining it for the first time, therefore I'm telling this to you. If you will multiply, you will get AB only over here, correct? So what does it mean? If you compare this thing and this thing, what will you get? Can I not say that AB is equal to 6? There is no other possibility, but you will get AB is equal to 6 over here. So what are the possible values of A and B? Tell me. The possible values of A and B, they can be equal to plus minus 1, plus minus 2, plus minus 3 and plus minus 6. Yes or no? Tell me, guys. Because you want to get 6 over here. So therefore it is plus minus 1, plus minus 2, plus minus 3, plus minus 6. This is called the integral root theorem. It is not a theorem as such, but I don't know why in books they give it the name of a theorem, because maybe you get confused and something like that. Hello Ajit, welcome to the session. Is it clear? This is known something called integral root theorem, that the possible zeros are this. Now you want which one is the actual zero of this polynomial. For that you just have to put it. Suppose the name of the polynomial is p of y. So let us find p of 1 over here. These are the possible values. Possible values you have to check. You are not doing hit and trial. You got it? Maybe in this school they might have taught that you can do by hit and trial and something like that. You don't have to do hit and trial. Obviously, if you are joining it for the first time, you will not be able to understand, because we are running the whole series. The basics of polynomials and the factor theorem, the remainder theorem, we have already done on the Infinity Learn Class 9 and 10 YouTube channel. Please check out the playlist named as Pratham for grade 9 students, JB Learning. I hope you understand that. Obviously, if you will join in between, see, it is not possible for me to do the whole thing again, because we have got classes done daily, right? So over here, let's check for p of 1. So what is that p of 1 will be? Just put 1 in the polynomial. So 1 square minus 5 into 1 plus 6. So is it equal to 0? This is not equal to 0. You see, this is not coming to be 0. So let's put p of minus 1. What is p of minus 1, guys? Minus 1 square minus 5 into minus 1 plus 6. Is it equal to 0? No, this is not equal to 0. You got it? Now let's put p of 2. We are talking about only possible values, na? See, apart from these, no other zero of the polynomial can be there. That we have got already over here. So can I find p of 2 over here? What is p of 2? In the polynomial, just put y is equal to 2. So 5 into 2 plus 6. Yeah, this will be equal to 0. 6 plus 4 is 10. Minus 10, that is 0. So you see, p of 2 is coming out to be 0. What does it mean? It means that y is equal to 2 is a 0 of this polynomial. You got it? Y is equal to 2 is a 0 of this polynomial. Now can I find p of minus 2 over here? Is it coming out to be 0? So minus 2 square minus 5 into minus 2 plus 6. You see, this is coming out to be positive only, not equal to 0. Correct? Now let's talk about p of 3. Possible values only we are talking about. So p of 3, if I will find, what will I get? 3 square minus 5 into 3 plus 6. So this is equal to, this is coming out to be 0. So what does it mean? That y is equal to 3 is a 0 of this polynomial by factor theorem. Y is equal to 2 is a 0 of this polynomial, and y is equal to 3 is a 0 of this polynomial. Now do I need to check again? Tell me. We don't need to check. This is a quadratic polynomial and we have got 2 zeros of that. So we don't need to check it. So what does it mean? That the polynomial can be represented, the zeros we have got 2 and 3. So the polynomial over here can be represented like this: y minus 2, y minus 3. This is the required factorized form of this polynomial. Is it clear to every student in this session? I'm again saying this is very important. If you will not understand factor theorem properly, you can never factorize a big polynomial, something like cubic polynomial or a quadratic polynomial, or sometimes a 5-degree polynomial, that is a quintic polynomial. Sometimes you can do, but most of the times they will give you a polynomial which can be factorized using factor theorem only. Is it clear to every student in this session? Moanza, Deepika, Yash, is it clear? Ajit? So this is something called integral root theorem. It might not be there in your school book, NCERT, and you don't need to know it as a theorem as well. Don't bother about the theorem. You just need to know the concept involved in that. I hope it is clear to you. So this was about quadratic polynomial. Now how can you factorize this cubic polynomial, guys? Can you tell the answer to it? X cube minus 2x square minus x plus 2. Can you factorize this cubic polynomial? And tell me the answer over here, guys. So basically, normally you are not able to do grouping in a cubic polynomial. Most of the times you will not be able to think. See, again it depends. Cubic polynomial can also be factorized using splitting the middle term, but it becomes complex when the roots are not simple, right? You have to think. But this is a simple polynomial, although it is cubic, but still you can factorize it using grouping. So what I can do, can I not say this is the first group, this is the second group? Out of the first group, can I take x square as common? So x minus 2 will be left. Out of the second group, I can take minus 1 as common. So x minus 2 will be left. Is it clear up till here? So you see, out of the whole expression, can I not take x minus 2 as common? So I'll be left with x square minus 1. So haven't we factorized this cubic polynomial without using factor theorem as well? But this will not happen every time. Please understand that. Now this can further be factorized x square minus 1. I can write it like this, x square minus 1 square. So can I not use a square minus b square identity, that is equal to a plus b, a minus b. So this is x minus 2. Can I not write over here x plus 1, x minus 1. So isn't it the required factorized form of this cubic polynomial? Tell me. But every time this will not be possible. Understand that. I had taken this question just to show that yes, cubic polynomials can also be factorized without using the factor theorem. Although every time it can be factorized without using the factor theorem. But what happens is actually you are using the factor theorem only. You got that logic or not? See, you are thinking of taking something common. What is that? Maybe you are not directly saying that I am using factor theorem, but basically you are thinking of taking something common, something like that. Ajit, just regrouping Ajit, take this group and take this group. Out of the first group, I am taking x square as common, so x minus 2 will be left. Out of the second group, I can take minus 1 as common, so x minus 2 will be left. Out of the whole expression, I can take x minus 2 as common, so x square minus 1 will be left. Now x square minus 1 can be written like this. You can use a plus b, a minus b formula, so you can write it like this. So this is the required factorized form. Is it clear, Ajit? So let's do the next question. Similar question over here, factorizing a cubic polynomial. So you can obviously use factor theorem as well, but suppose it can be done without using factor theorem. Why will you use factor theorem? Why to make it complex? I'm just saying that. If suppose no factor theorem is required, it can be done easily, why will you use the factor theorem? Okay. Obviously if it is given in the examination that you have to specifically use factor theorem, then you have to do that. There is no other way out of that, right? So you see, this question can also be done by regrouping the first group, the second group. Out of the first group, can we take y square as common? So you'll be left with 2y plus 1, right? Now out of the second group, again I can take minus 1 as common, so 2y plus 1 will be left. You see over here, right? Now out of the whole expression, I can take 2y plus 1 as common, so I'll be left with 2y plus 1, and then y square minus 1 will be left. Now you see, y square minus 1 can be further factorized. This is 2y plus 1. Y square minus 1 can be written like this. So can I not further factorize it using a square minus b square formula? So this I can write as 2y plus 1, and I can use a square minus b square formula, that is a plus b, a minus b. So y plus 1, y minus 1. So this is the required factorized form of this cubic polynomial. Exactly, but it will be further factorized, Ajit. Y square minus 1, don't leave it like that, because it can be further break down into a plus b, a minus b, that is y plus 1, y minus 1. I hope it is clear to every student in this session, right? So see, up till now what we have done, we have factorized a quadratic polynomial using splitting the middle term and then using the factor theorem. And now we have done two questions on the basis of factorization of cubic polynomials by taking common. We are not using factor theorem. But every time it will not be possible. For example, in this question, can you factorize this using taking common like the previous question? you see, you'll find it more complex. You'll not be able to do it. Maybe you'll be able to do that. I'm not saying that, but it will waste your time unnecessarily. For example, this question you'll not be able to do like we did in the previous session. Maybe you'll be able to do, but it will take time. That's what I'm saying. So you have to save your time as well, right? It's not just about doing it correctly. You have to do it in some time frame. I hope you understand that. So you see, this is a cubic polynomial. Understand it very properly. And you see the leading coefficient is 1 over here. And suppose the zeros of this polynomial are a, b and c. So can I not write this polynomial like this using the factor theorem, guys? X minus a, x minus b, x minus c. Using the factor theorem, I can write this polynomial like this. X minus a, x minus b, x minus c. You can understand it like this. Now basically, if you will multiply this polynomial, if you open up this polynomial, what will be the last term which you will get after multiplying? Will it not be ABC? This is the constant term. You got it? If you multiply, open up these three brackets, the very last term will be ABC or not? Tell me, guys. Very simple logic. The very last term will be ABC, and that will be the constant term, a term free of the variable. And in the left hand side, the term free of the variable is this. So can I not say that this is equal to minus 5 only? Tell me, guys. So basically the three zeros are A, B, C and their product is minus 5. So what are the possible values of A, B and C can be there? Tell me. Those will be the factors of minus 5, you can say. So plus minus 1 and plus minus 5. Is there any other possibility? Tell me. Is there any possibility for the zeros of A, B, C? I would say no. Not getting, Ajit? Okay. Up till here, is it clear, Ajit? That we can write this cubic polynomial like this if A, B and C are its zeros. This thing is clear, na? And the leading coefficient, the coefficient of the highest power of the variable is 1. So therefore, this will also be 1. Clear or not, Ajit? Hello, Shweta. Welcome to this session. Now, if you open up this bracket, Ajit, will I not say that the very last term, sorry, it will be minus. I'm sorry for that. It is not plus, it will be minus only because you see three negative signs are there, na? So the very last term, the constant term will be minus ABC or not. If you open up this bracket, just think that in your mind, guys. The very last term will be minus ABC. This is the term free. This is the term independent of the variable x, right? And in the left hand side as well, the term independent of the variable x is minus 5. So can I not say that minus ABC is equal to minus 5 only? So what are the possibilities for A, B and C over here? The possibilities of A, B and C are plus minus 1 and plus minus 5. Is there any other possibility? 5 is a prime number. There is no other factor of 5 except 1 and 5. Except 1 and 5. It's a prime number. So you just have to put and check these. That's it. Is it clear? So suppose the name of this polynomial is P of x. So can I find P of 1, guys? We are just talking about the possibility. So we are talking from here only. So what is P of 1, guys? It is 1 cube minus 3 into 1 square minus 9 into 1 minus 5. Is it coming out to be 0, guys? No, this is not coming out to be 0. This is not 0. This is not 0. Now what about P of minus 1 over here, guys? P of minus 1 over here is minus 1 cube minus 3 into minus 1 square minus 9 into minus 1 minus 5. What is this coming out to be, guys? Minus 1 minus 3 plus 9 minus 5. So this is coming out to be 0. So what does it mean? Can I not say that x is equal to minus 1 is a 0 of this polynomial? X is equal to minus 1 is a 0 of this polynomial. Now can I find P of 5? P of 5, what is that coming out to be? 5 cube minus 3 into 5 square minus 9 into 5 minus 5. What is that coming out to be, guys? You see, this is 125 minus 5. So what is this coming out to be, guys? Can you tell that? So I think this is 125 minus 125 only, that is coming out to be 0. So what does it mean? It means that x is equal to 5 is also a 0 of this polynomial. You got it? Thank you, Vivek. A very congratulations to you. Okay, I hope it is clear that x is equal to minus 1 and x is equal to 5 are the zeros of this polynomial. You got it? Now, can I find P of minus 5 over here? P of minus 5 can I find over here, guys? So let us put minus 5 over here in the polynomial itself, right? So minus 5 cube minus 3 into minus 5 square over here, and then we'll get minus 9 into minus 5. Is it coming out to be 0, guys? Just calculate and tell me the answer. So this is basically minus 125, and this will come out to be what, guys? So minus 5, let me check it, minus 125, and then we have got this. So yeah, this will not come out to be, so this is not coming out to be 0 over here. So I hope it is clear to every student over here. I hope this thing is clear to every student in this session. So what does it mean? That these are the zeros. Now we want to know the other zeros as well. So what the method is this over here, right? The method is this. If you put P of minus, well, let me check once again. So okay, this minus 125, this is, okay, this will not be equal to 0, obviously. So it means we have got these two zeros over here. Now you will say this is a cubic polynomial. We don't know the other zero, right? We must get one more real zero if there is one more real zero, right? It can also happen like that. So what will we do over here? For that, the basic method in your school examination is what? You will find only one zero using factor theorem. For your school examinations, you find only one zero using factor theorem. So we have got P of minus 1 to be equal to 0, P of minus 1 to be equal to 0. Using the factor theorem we have got for the other zero. You see, if x is equal to minus 1 is a 0, we will say that x plus 1 is a factor of this polynomial. Using the factor theorem, if x is equal to minus 1 is a 0 of this polynomial, we can say that x plus 1 is a factor of this polynomial, right? Using the factor theorem. Now can I do one thing? See, we have got this space, we have got x plus 1, right? So what can I do? Can I divide this polynomial by x plus 1? This is another method which I am explaining. You see over here. Let's divide it using the long division method. I expect that you already know the long division method. You see, x square will be there. So x cube plus x square will come up. Now change the sign and then add. So you will get minus 4x square and minus 9x, right? So I'll get minus 4x over here. So it will give you minus 4x square minus 4x over here. Change the sign and add. So this will give you minus 5x minus 5. So I can multiply over here by minus 5. So I will get minus 5x minus 5. Change the sign and add. You'll get 0. So what does it mean, guys? It means that the polynomial this over here is nothing but equal to x plus 1 into this quotient or not? Tell me. X square minus 4x minus 5 or not, guys? Tell me. This polynomial over here is equal to x plus 1 into the quotient, that is x square minus 4x minus 5 over here. So can I factorize this quadratic polynomial using splitting the middle term, guys? And that you can do in your mind as well. You see, because if you will multiply these two, you'll get minus 5x square. So you have to split the middle term in such a manner that the multiplication of the two terms must be minus 5x square. So you see, I can write it like this because minus 5x into x will give you minus 5x square. I'll tell you, Shweta, just give me some seconds. So you see this group and this group. I'll tell you the whole thing after this thing. So just let me take the common x out of the first group. So x minus 5 will be left. Out of the second group, I'll get 1 as common. So x minus 5 will be left. I hope that is clear. Now out of the whole expression, what can I do? I can take x minus 5 as common. So x plus 1 will be left. I hope that is clear. So can I not say that this is the required factorized form of this cubic polynomial? Yes or no? Now actually, what is the answer to this question? See. Again, I'm saying the first thing is to find the possible zeros. You understand that? That you can find using the factor theorem. The last term over here, the factors of the last theorem can be the possible zeros. I had given the logic behind that. You see, I had given the complete logic behind that why the factors of the constant term are the possible zeros of the polynomial. You got it? So you just need to put one by one and just check that which value is giving the value of the polynomial to be equal to 0. So those values of x will be the zeros of the polynomial, and hence you can find the corresponding factor. But in this specific question, what is happening is, you see, we have got at only two values of x we are getting 0. At only two values of x we are getting to be equal to 0. So will you say that only two factors are there for this cubic polynomial? The answer is no. Will you say that this polynomial is having only two factors? It is not possible. It's a cubic polynomial. So what will you do? You can take x plus 1, or if you want, you can take x minus 1 as well. You got it? You can take x plus 1 or you can take x minus 1, because by factor theorem, x minus 5 and x plus 1, I'm sorry, this is x minus 5 and x plus 1 are the factors of this polynomial. So in order to get the other factors, what you can do? You can take this actual polynomial and divide it by x plus 1 or x minus 5, whatever you are getting, and you'll get a quotient over here. Obviously it will be a quadratic, right? A quadratic polynomial. Then what you can do? You can just factorize the quadratic polynomial. Factorizing quadratic polynomial is very easy for you. Using splitting the middle term you can do. So in that manner you will get three factors of this polynomial. So any two out of these methods is correct. Is it clear, Shweta? But in this specific question, unfortunately, we were not able to get any other 0. Otherwise, I was doing using factor theorem only. You got it? I was doing using factor theorem only. Got that logic? Okay. So in the same manner, you can do the next question as well. Just practice. This is a very important thing to understand factor theorem. It is very important. And obviously, I'm giving this as homework. Please comment your answer in the comment section after this session. So that's all we needed to discuss in this class. We'll meet in the next class, guys. We'll be doing more questions on factorizations. This time I'll try to get some identities as well, because on the basis of identities as well, you can factorize polynomials. You have studied that in grade 8. So that's all we needed to discuss in this class, guys. We'll meet in the next session. Don't forget to like, share and subscribe to the Infinity Learn Class 9 and 10 YouTube channel. And also don't forget to subscribe to the Telegram channel as well. The link of this is given in the description below.